What is the gap that the proposed method aims to address in the existing research on language models?
The proposed method aims to address the gap in existing research on language models regarding the understanding of how language models utilize multidimensional representations. The research in the field has primarily focused on one-dimensional features and linear representations, while the specific algorithms and mechanisms behind the capabilities of language models, especially in utilizing multidimensional features, remain largely unknown. By introducing a method to discover and analyze multidimensional features in language models, the study bridges the gap between the existing research on one-dimensional features and the potential use of more complex, multidimensional representations in large language models.
How does the proposed method work in finding multidimensional features using sparse autoencoders? Illustrate step by step.
The proposed method for finding multidimensional features using sparse autoencoders works as follows. 1. Cluster dictionary elements. The first step involves clustering dictionary elements based on their pairwise cosine similarity or Jaccard similarity. This clustering helps identify groups of dictionary elements that correspond to specific multidimensional features. 2. Run sparse autoencoders, SAEs. For each cluster identified in the previous step, SAEs are run on all hidden states in the layer. During this process, dictionary elements not belonging to the cluster are ablated, focusing the reconstruction on the specific multidimensional feature found in the cluster. 3. Examine reconstructed activation vectors. The resulting reconstructed activation vectors are then examined to identify irreducible, multidimensional features. It is crucial to ensure that the reconstruction is not separable, indicating the presence of meaningful, multidimensional representations. 4. Visual inspection or automated testing. The examination of the reconstructed activation vectors can be done manually by visually inspecting PCA projections for known multidimensional structures like circles. Alternatively, automated tests, such as those for irreducibility defined in the text, can be applied to validate the presence of multidimensional features. 5. Success on toy datasets. The method has been successful on synthetic datasets with known irreducible multidimensional features, providing confidence in its ability to identify and reconstruct such features in language models. By following these steps, the method effectively leverages sparse autoencoders to discover and analyze multidimensional features in language models, particularly focusing on identifying irreducible and non-separable representations that contribute to the model's understanding and processing of complex concepts like circular arrangements of days and months.
What are the theoretical or practical benefits of discovering multidimensional representations in language models, according to the paper?
The theoretical benefits of discovering multidimensional representations in language models, as outlined in the paper, include refining the understanding of model behavior beyond simple one-dimensional linear representations. By identifying multidimensional features that are non-separable and irreducible, researchers can generalize the notion of features to higher dimensions, providing a more comprehensive view of how language models process information. This discovery allows for a deeper exploration of the underlying algorithms that utilize these multidimensional representations, potentially leading to the development of formally verifiable programs based on these representations. Additionally, the paper suggests that uncovering these multidimensional representations is crucial for revealing the true variables within language models, which is essential for advancing the interpretability and transparency of these models. On a practical level, the ability to extract multidimensional features using methodologies like sparse autoencoders offers a practical approach to discovering and understanding these complex representations within language models. This work represents an important step towards unraveling the intricate mechanisms and structures within language models, paving the way for more sophisticated and interpretable artificial intelligence systems in the future.
How are the circular representations in large language models validated in the paper?
The circular representations in large language models are validated in the paper through a series of experiments and analyses. Firstly, the paper introduces tasks related to modular arithmetic, such as modular addition in days of the week and months of the year, hypothesizing that models will use circular representations for these tasks. Intervention experiments are then conducted on Mistral 7B and Llama 3.8B models to show that they indeed use circular representations for these tasks. Additionally, the paper performs layer-wise activation patching and explanation via regression (EVR) techniques to isolate the circuit for computing the target output, revealing that MLPs on top of the day and month tokens, a copy to the token before the computed result, and further MLPs are involved in the computation process. Furthermore, the paper applies sparse autoencoders to discover irreducible, multidimensional features, finding interpretable circles in the hidden states of GPT-2 and Mistral 7B models. These analyses and experiments collectively provide evidence that circular representations are fundamental units of computation for certain problems in large language models, validating their existence and usage in model computations.
What specific tasks are proposed to demonstrate the usage of circular representations in language models, according to the paper?
The specific tasks proposed to demonstrate the usage of circular representations in language models according to the paper are the weekdays task and the months task. In the weekdays task, the prompt involves performing day-of-the-week calculations, such as determining what day it would be 2 days from a given day like Monday. In the months task, the prompt involves calendar calculations, such as figuring out what month it would be 4 months from a given month like January. These tasks are designed to showcase how models use circular representations for problems related to modular arithmetic, specifically focusing on days of the week and months of the year. The paper presents these tasks as evidence that models indeed utilize circular representations for certain computational tasks.
What are the limitations mentioned in the paper regarding the findings and methodology of discovering multidimensional features in language models?
The limitations mentioned in the paper regarding the findings and methodology of discovering multidimensional features in language models include uncertainties about the scarcity of interpretable, multidimensional features and the effectiveness of the clustering technique in identifying them. The definition of irreducible features had to be relaxed to align with practical constraints, raising doubts about the accuracy of the theory in describing model representations. The study did not uncover a small subset of MLP neurons responsible for implementing the clock algorithm, leaving unanswered the extent to which models utilize multidimensional representations for algorithmic tasks. Additionally, the experiments were conducted only on models up to size 8B, while indications from recent research suggest that representations may become more universal with larger model sizes.